So here goes example 1 from chapter 15. This is 15a about vectors. The typical vector problem whereby in this case Jacques wants to swim a river and there's a current in the river of 1/2 meters per second. Jacques can swim 1.5 meters per second and he needs to choose the direction that he needs to swim in. Now if Jacques dives in straight towards B and swims without allowing for the current, what will his actual speed and direction be? So Jacques is going to swim straight in and straight to the other side there. The current, which is C, is that way. So the resulting vector is going to be there. You just basically complete the parallelogram, which in this case is a rectangle. And here's the right angle. So this is S for Jacques swimming. This is C for the current. And that vector there is R for the resulting direction and speed. So we can say for A, the vector S, we know that one, it's a vector that only has a vertical component. It is 0, 1.5. We know the vector C as well. It's the current which only has a horizontal component and it's 0.5, 0. Then we know the resulting vector occurs by adding up C plus S. So that vector could be written as a 0.5, 1.5. And now what we want to know is the length of the resulting vector, which we could have found by using Pythagoras here, because it's just a rectangular triangle, but we can find it by just calculating the length of the vector, which is the root of 0.5 squared plus 1.5 squared. And the answer there is going to be 1.58 meters per second. You do that. Now for part B, oh sorry, not part B, the direction that he swims in. Well, the direction can be denoted with theta here. So there's our angle theta. And when you look at theta and you look at the triangle that theta is in, there, and of course we can put C on the top there as well, then you will see that theta, the tangent of theta to be precisely, is the length of C over the length of S. So that is 0.5 over 1.5. So to find theta, we take the arc tangent of 0.5 to 1.5, which gets us to 18.4 degrees. And that's that. For part B, we just need a new river. Let's make it blue. There we go, a new river. And we have point A here still. We have point B here. Now this time, Jacques wants to go from A to B still, but he's not going to swim there directly. Instead, he's going to swim a little bit against the current. He's going to swim in that direction, so that when the current takes him, it brings him to point B. So we have the current C again, and this is now S for Jacques swimming, and this is the resulting vector, which is perpendicular to the river. Now in this case, We're first going to find the angle in part I, and the angle again, I'll call it phi this time. And when you look this time, phi is in that same sort of triangle, but it is not the opposite and the adjacent, but it's the opposite and the hypotenuse that we know. So this time we can say that the sine of phi is going to be the length of C over the length of S, which is the 0.5 over 1.5, and therefore phi, I can take that away too, is arcsine 0.5, 1.5, which comes to 19.5 degrees. So it's not the same angle as in part A, because it's not the angle that is taken by the current, but the angle in which he swims towards the current. And that will bring him to point B, that angle, 19.5 degrees. Now, the second part is fairly simple, because if we stick to SOHCAHTOA, right, so SOHCAHTOA, then we know that what we're looking for here is the adjacent side, and we know the angle, and we know the hypotenuse, so we need to use that bit. So we can say the resulting vector, the length of that vector, is the hypotenuse times the cosine of phi, which is 1.5 cosine 19.5. Comes down to 1.41 meters per second. Now, of course, you can use Pythagoras here as well, because we have that triangle. It's just that the right angle is there, and what you're after is one of the shorter sides. So we could write that, so this is a big OR, the length of S squared is the length of R squared plus the length of C squared, which means that the length of R is going to be the root of 1.5 squared, take away 0.5 squared, which is the root of 2. And as you may know, the root of 2 is 1.41, although that answer is approximate and this is an exact answer. And I should have done that here as well. These are approximate answers, really. So we want to get our notation right, then we need to stick to that. So that's example 1 of 15a.